Hey, it's Flora, and you're listening to Science Friday. On a hot summer day, there is nothing better than a dip in a cold pool. But you know who can ruin that for you? A scientist who studies pool chemistry. What chemical reactions are happening in that swimming pool? My next guest has researched this for decades, including at the Paris Olympics pool, and is here to share his findings. Dr. Ernest Blatchley is a professor of environmental engineering at Purdue University. Welcome to Science Friday. Thanks for being here.
Thank you for the invitation.
Is it fair to say that a swimming pool is an active chemistry experiment?
It's really a reactor. People jump in the pool and they leave various things behind that might have been on their skin, including sweat, deodorants, things that they apply to their skin like makeup or sunscreen. There's also chlorine in the pool, and people urinate or pee in the pool more often than you would think.
Wait, what do you mean more often than I would think? Have you quantified this?
I have not personally, but I think if you were to do a survey, I have done this sort of informally. If you were to do a survey of people who swim in a pool, first of all, ask them to close their eyes so that they can't see the responses of other people in the room, but ask them how many people pee in the pool. You'd see, I don't know, 3/4 of the people in the room are going to raise their hand. So it's...
Are you surveying adults?
Yes.
Okay. I don't know that I want to know this. Okay, so keep going.
Well, if you were to talk to competitive swimmers, for example, they commonly will not get out of the pool. And yet all of them, or virtually all of them, have 1 or 2 water bottles waiting for them at the end of the lane when they're resting between sets. Do the math. So it's just the way it goes.
Okay, so I'm hearing that there's lots of different ingredients. Why is it a reactor? What happens with those things we leave behind and the chlorine?
Well, so we use chlorine in pools to inactivate microbial pathogens that could cause other problems. And chlorine is pretty good at that. But chlorine also reacts broadly. It's a very reactive chemical, and it's going to react with many things that are present in pools. And among those, let's just say, human body fluids that I described a few minutes ago, there's a lot of compounds that contain organic nitrogen. And it happens that organic nitrogen in particular reacts very rapidly with chlorine. And some of the products of those reactions are unpleasant and have potentially adverse human health effects.
Give me an example.
Perhaps the sentinel compound among the various compounds that we and others have identified is a chemical called trichloramine. You're probably familiar with this chemical, at least by its smell. So if you're ever around an indoor swimming pool, especially one that's not operated particularly well, there's oftentimes this sort of chlorine odor that most people will recognize. That is, in fact, largely attributable to trichloramine.
I'm not smelling the chlorine. I'm smelling trichloramine
You're smelling a product of chlorination, exactly. So that chemical is interesting because it's volatile, which means it has the ability to escape from the liquid phase to the gas phase. So it's going to end up in the air that we breathe. It is a chemical that's known to cause problems for the human respiratory system, and it also causes things like corrosion. So if you look around in an indoor pool, oftentimes you'll see stainless steel that is, stained. It's been corroded, and much of that corrosion is attributable to trichloramine. So, think about a chemical that has the ability to corrode stainless steel. It's probably not going to do nice things to your lungs either.
What about your skin? Do we have to worry about it on our skin?
Yeah, there are some people whose skin is irritated by chloramines broadly, including trichloramine, but it's a pretty, I don't honestly know the sort of medical explanation for this, but that's pretty variable among people, and it's probably some sort of allergic response or something like that, but not everyone reacts that way.
Do we know the health effects of breathing it in, or at what level it becomes damaging? If I'm in an indoor pool and I'm smelling it, and it's very strong, does that mean the dose is high? Like, can I trust my nose?
Well, if you can smell it, so the human sense of smell is also pretty variable among people. So my nose is almost useless. But there are a lot of people who have very sensitive senses of smell. For even people that have relatively sensitive senses of smell, if you're smelling if you have that sort of chlorine odor in an indoor pool, it's probably at a concentration that's going to cause problems.
I mean, are there alternatives to chlorine that are less reactive but would do the job we need done?
There are. I mean, there are a lot of pools that use in their recirculating treatment systems UV to treat the water, and it has some overlapping characteristics with chlorine. But I, rather than remove chlorine from the pool, probably a better strategy is to use less chlorine and to improve the hygiene habits of the swimmers. Because it's, these reactions require both sets of reactants to be present, the chlorine and all those other things that are present in human body fluids. So if we cut back on the human body fluids, I think it's likely to be probably a better solution than eliminating the chlorine. And there certainly are pools. I mean, you've probably been in pools where you can't smell that sort of characteristic odor, and you've probably been around pools where that odor is pretty strong. I would say maybe a good idea to avoid the latter.
That's every water park ever.
Possibly. I'm not going to address that.
Is there a way to reduce the trichloramine in the air if we can't convince people to stop peeing in pools?
Again, the hygiene thing is the best way to go, but humans are sort of strange creatures in that we don't change our habits rapidly, and those habits are formed over long periods of time. So there are technologies that will intentionally break those compounds down so that they don't have the opportunity to react with chlorine.
You have researched some pretty fancy pools. What brought you to the Paris Olympics?
So in the swimming community, indoor air quality it's a big deal because it has the potential to, adversely affect the athletes. But I think for just everyday swimmers also, it's a relevant issue. So the swimming community broadly is interested in improving indoor air quality. And I was contacted about the Paris Olympics, and the company that installs the facility that was built there, the temporary indoor pools that are used for many high-level competitions, because they had apparently read some of the work that we had published, because there was an opportunity there to conduct an experiment that would allow us to evaluate the performance of this air stripping system that was developed specifically for that purpose.
What is air stripping? What was the system?
Sure. So air stripping is a process that promotes the transfer of volatile chemicals from the liquid phase to the gas phase. So basically what we want to do is literally strip those volatile chemicals from the water. And the way that this is often done is to introduce tiny bubbles into water in a controlled setting, and then having those bubbles move upward through the water. And as they do, the volatile chemicals will move into the bubble. And then if you can collect the air off the top of that column, whatever that water column is, and send it away from the water, or in this case, away from the pool, then you have a mechanism to basically bypass where the people would ordinarily be breathing it.
And so you're like grabbing these toxic bubbles and then shunting them somewhere else.
Exactly, to the outside. I mean, they're going to end up outside regardless. So really, it's this sort of a short circuit. Rather than go through the indoor space where the swimmers and the spectators and the lifeguards and everybody else is, it's just going straight outdoors, rather than going through the lungs of all those people I just listed and then outdoors.
So I'm thinking of a pool and how water sort of goes over the edge into a filter. Is that where this happens?
That's exactly right. So if you're familiar with pools, and it sounds like you are, typically what will happen is water will flow over a gutter or over the edge of a gutter, and it'll be fairly shallow in this gutter, and then it'll move to a treatment system, it'll be treated, and then it'll be pumped back into the pool. It's recirculated that way. In this system, what they did was they designed intentionally a deep gutter so that there is, quite a bit of depth to the water was maybe 6 or 8 inches deep, something like that, but much deeper than you normally have in the gutter around a pool. And then they put perforated pipes in the bottom of that gutter, and they introduced compressed air to generate bubbles. So those bubbles then would move through that 6 or 8 inch deep water column, and then they applied a negative pressure or a vacuum to what's called the headspace. That's basically the air above that water column, and they draw that air off and then vent it to the outside. And again, the idea there is it strips those chemicals, but does so in a manner that bypasses the place where people are breathing.
Did it work?
Yeah, it worked really well.
Was the air better?
Yeah, it was quantifiably better. So we had instrumentation set up at the Olympic venue in Paris, and we were able to demonstrate that this system worked well.
So trichloramine, is this something that we don't have to worry about so much in outdoor pools because you're not in an enclosed space, or do we worry about it there too?
I think that's an accurate statement. I would say that when we first started this work, we identified 11 compounds that we found in every chlorinated pool that we looked at, one of which was trichloramine. So what we're talking about here really is focusing on trichloramine really for a couple of reasons. One, it is the chemical that has caused the greatest concern because people are familiar with it. We all smell it, that sort of thing. And there are known human health effects. And that's not conveniently true for most of the other volatile chemicals that are present in swimming pools.
So this is the one we know about, but there might be others to worry about.
There are, for sure. There are others. Whether they're present at concentrations that should cause us concern is a different question, and it's a complicated question.
Do you swim?
I do.
Has your own research ever given you pause?
Absolutely. We've been doing this sort of work for, close to 25 years. And about 5 years in, I sort of made a decision because the pool that I was swimming in at the time, I would get out of the pool and I'd be coughing and sneezing the rest of the day, and it just wasn't all that pleasant. So I found other ways to exercise for a couple decades. And then maybe 5 years ago, I sort of stumbled back into the pool again. And the pool that I'm swimming in now is really run very well, and the air is not a problem. And for me, what's relevant is that those symptoms don't show up anymore.
Thank you for taking the time.
My pleasure. Thanks for the invitation.
Dr. Ernest Blatchley is a professor of environmental engineering at Purdue University. This episode was produced by D. Peter Schmidt. If you have any questions about the science of your summer, drop us a cannonball at 8774-SciFri. I'm Flora Lichtman. Thank you for listening.